So, hello friends, hope you are doing good and welcome back to my channel. Today we are at day 25th of it and we have a medium level question in front of us. This question is a really tricky and nice one, and if I have to rename it, I will be like making the name as counting possible edges between disconnected components. I would have given this name, I will tell you why. So, coming to the question, it's question 2316, count unreachable pairs of nodes in an undirected graph. Okay, so what we are given is we are given the n value means these are number of nodes present. These are numbered from 0 to n minus 1. And okay, and finally we are given a 2D array which marks the edges, and the edges are mentioned very clearly that they are undirected. Undirected means, for example, if I say 0 comma 1, that means I can travel from 0 to 1 as well. At the same time, I can travel from 1 to 0. Undirected means you can travel in either way, right? And the yesterday's question, if you remember, they were not undirected, they were directed edges, so you cannot travel in that way, right? Fine. Now, there is existing undirected edge between nodes A of I and B of 1. Okay. Return number of pairs of see, this is the question. Return the number of pairs of different nodes that are unreachable from each other. Please take a second and try to understand what it means. Return the number of pairs of different nodes that are unreachable from each other. Coming to the example one, see, just try to see. I am only trying to logically understand what this statement means. I am in example one. I am starting from zero. All possible nodes are reachable from here, right? There is nothing which I can't reach from zero. Similarly for one, similarly for two. That means answer is zero here. Fine, we are correct. Now coming to this example, example number two, I am at zero. Which all nodes I can travel? Okay, the red ones are the edges, right? They are like they are not direct edges; they are undirected edges. That means you can travel from zero to two. You can travel back from two to zero also. So tell me which edges are like which nodes are traversable from zero. You can clearly see that it's 2, 4, and 5. I cannot reach 3 from 0. Similarly, I cannot reach 1 and 6 from 0. So by now, I think by the time I'm saying this, you might have got the idea that this is all about connected components. If 0 is a part of a connected component, then it can only reach nodes which are in that component. It cannot reach nodes which are not connected to that component. For example, see, this time I will try to make my naming conventions very clear so that my examples are precise and very easy to understand. This particular square which you are seeing 0 to 4 and 5, I will call it as component 1. 1 and 6 is my component 2, and 3 is my component 3. Okay, I will be using these terms only now. Okay, so 0 is a part of component 1. 0 can only travel and reach nodes which are in component 1. You might be, I can see this is very logical, right? There's nothing much to understand in this, but it can never reach a node in component 2, okay, which is 1 and 6, okay, because there is no way from, see, it's a disconnected component, right? Component 1 and component 2 are disconnected. Similarly, component 1 and component 3 are disconnected. They are all disconnected components, right? So again, try to read what they are asking. The number of pairs of different nodes that are unreachable from each other. So by now you will be understanding that there is no way I can reach from a node in component one, this thing, to a node in component two or in component three, right? Component one is totally separated from component two. Component two is totally separated from component three. And each of them, in any two, if you pick any two components, they are always separate from each other. You cannot travel from there to the other component. So if I take a node in component one and if I take a node in component two, that means that will form a pair which will contribute to my answer. For example, I am taking 0 from my component 1, I am taking 1 from my component 2. Definitely, it will be a part of the answer you can see here. Next, let us say some random thing I will take. I am taking component 5 from this, I am taking component 6 from this. Okay, 5 and 6. You can clearly see this is also a part of the answer. So what it means is what are the factors which are contributing to my answer? Always I have to take a node from a component which is not connected to the other component. So there are two nodes we need, right? See, each of the answer has two nodes. This thing and this thing. The first one will come from a component which the second one is not a part of. As simple as that. The first one will come from a component which is disconnected from the second component from which the second node is coming. So if I take 0 from here and if I take 3 from here, right, it will be a contributing to my answer. Please read the question again. Return the number of pairs of different nodes that are unreachable from each other. It's very simple. See, I will tell you what I'm going to do now. First, I will find the number of disconnected components. In this case, we have three disconnected components. Then what I will do, then we need a simple maths, okay? then we need just a few multiplications and we are there in the answer. So now what those multiplications are? For example, see, it's simple math only. There's nothing rocket science here. In my current node, there are four, like this component one has four nodes, component two has two nodes. So now how to find how many number of pairs it will have? So let us see this. What we can do is, from component one, I can take one node. From component two, I can take one node. So how many ways we can do like that? There are four number of nodes in component one. There are two number of nodes in component two, right? 4 into 8. Now there are four number of nodes in component one. There's only one node in component two. So 4 into 1, which is 4. So what is the total? 4 plus 2 equal to 12. That means there are 12 possibilities where the first node is from component 1 and the second one is from the rest of the unconnected components. Okay. So the component 1 in itself is contributing to 12 to the final answer. Now what is the second way? See, this way we need to know the number of nodes in each of the components. That will take some more complexity while designing a solution. And in this case, we are given 10 by 5 complexity, right? That will be slightly difficult. But see, but n is given to us, right? Till now we have not utilized this n, right? It's simply given to us how to utilize this n. Till now what I'm doing, I am counting the number of nodes in each component, and like I am doing some maths here, right? I'm multiplying the number it's in one component to the numbers in another component. I'm getting some answer. But how to avoid that? How to make use of the total? There are four components in the component one. Sorry, four nodes in the component one. Now in total I have seven. Seven is given to me, right? What I can do is I can do 4 into 7 minus 4, which is also giving me 12. So this 12 which I was getting here, I can also get by multiplying 4 into the total minus 4, which is 12. This way also we can get this answer. This is what I'm going to use in my solution, right? See, this is simple maths here. If you know permutation and combinations, you can definitely understand this very, very clearly. Actually, this is what I am also recalling from my permutation combination lessons, and I'm doing it right now. So what we can do is, yeah, coming to the solution part. So please be clear that what our solution is, what the ask of the question is, and what we are doing. They are asking number of unreachable. See, total number of pairs from different nodes that are unreachable to each other, right? If there A comma B is a pair, then A should not be reachable to B. How it is possible? Only this only possible if A is from a connected component and B is from another component, but these two are not connected to each other. Okay. So what our answer will be? First, we will find number of connected components. Then we will try to do some maths here so that we can take one node from a connected component and we can take another node from a total disconnected component, which is in itself is a connected component, right? So see, as usual, see, these are as usual things. Like if you have been following my videos, by now you will be thorough with these things. Okay, this is how I'm making adjacency list. You can make it as a 2D array and you can do whatever you want. But see, in Python, these are easier. In Python, hashing is much faster than the array traversals and 2D, all those things, right? In 2D, actually, there is a lot of wastage also. If you are like good in this, please analyze and see. You will have a lot of wastages in it. Some will be blanks. But this way, I can ensure that there is no blanks involved, right? This is how I'm preparing my adjacency list. What my adjacency list will do is, see, A comma B are matches. What are A comma B? See, this is how the input is given, 0 comma 2. Okay, in this case, it will be A comma B. For me, it is A comma B. If A is not in H, I will initialize for key A. I will initialize a list. List is an array in which I will be setting B. If it is already initialized, what I will do, I will just append to the already existing array. This is my already existing array. To that, I will append a new value. Okay, this is for A comma B node because these are bidirectional. That's why I will do for B comma A also. See, please try to understand. This is for A comma B from A to B, and this is from B to A. Right? The same thing, exact same thing. We are just replacing B with A. Okay. Now we are declaring a set. Set. I will call it a visited set, which nodes I am visited. Then I am declaring a BFS traversal. See, if you have been following my previous questions, by now you will be knowing how Leetcode, step by step is increasing the difficulty. Previously, this used to be the single answer. Now it's part of an answer, right? And this is my answer to find the number of connected components and doing that maths, which I have showed above. First, let me explain what I'm doing in BFS. I am sending a node to my BFS function. Okay, non-local visited. See, it's not a declaration. Okay, this is the declaration. Here I'm just saying, just go above this function and use the node declared outside the scope of this function. It's not a separate declaration. Some of you have been asking me. So no, this is not a separate declaration. I am just saying there is a visited set declared outside the function. Just go and use that. Do not declare anything on its own inside the function. So whenever our variables are outside the function, we are supposed to do like that. Okay. So node is given to me. I am making it a queue. You can also use the normal list queue, but this is slightly faster. DQ is slightly faster. That's why if you have option in your coding competitions, always use DQ, right? Whenever there is need to use a queue. So while queue is not empty, this means while queue is not empty, I am popping the leftmost element. Okay, I'm showing it in element. Then I am adding it in the visited array. Then what I'm doing is I'm going if it's present in edge. That means if it is connected, that means see for 3 it will be false. For 3, if I come here, this will be false. For 1, 6 and all other nodes, it will be true. That means if 3 has edge, then go to that. Okay. For I in edge of element, that means for all neighboring nodes, I is the neighbor of my element. Okay. For all neighbors, what I have to do, if the neighbor is in visited, not in visited, then insert it in the queue. Otherwise, do not insert it. That means if what I will do is this will come for all its neighbor, I will be inserting them into the queue if they are not visited. If they are visited, I will not do that. Then slowly they will be popped one by one, and their neighbors will be popped inside. Okay, their names will be pushed inside. This is how BFS will function. BFS means, if you don't remember what BFS is, all it needs when I am at 0, at together I will push 5 and 2 inside the queue, right? I will pop 5 and 2 inside the queue. Then one of them will be, for example, 2 will be popped out, and its neighbor will be pushed. So all neighbors which are at nearest distance to it, which means the same distance to it, will be pushed inside at the same time. That is the idea behind BFS, right? I can have a separate video for that teaching it, but I am hoping that you are following my previous solutions, so I am not explaining it in detail, right? Now comes the maths part. See, I've done a lot of work this time to like trace it very precisely so that you don't get any doubts. Okay, we'll be doing it for the second example only. Okay, I am declaring a variable total nodes, which is of n. N is the number of nodes. Okay, total number of nodes. Previously, we said count is 0 currently. Okay, answer is 0 again. So this is how I'm calculating the total number of connected components for each node in n. That means from 0 to n minus 1. Check if the node is not in visited. If it's not in visited, call BFS of I. Then there are some calculations happening. We will try to trace it out. See, whenever I'm running this for the first time, 0th node will not be part of the visited array, right? Visited set. So it will be called for the 0. I'm tracing example 2 only, right? So what will happen? Count of nodes in this component will be, see what is the formula? Length of visited. See, after running the BFS, BFS is being called here, right? So BFS is being called here for 0th node. So what will be length of visited? Visited array will now have 0, 2, 4, and 5. Okay. So it will have length of 4. What is previously visited count nodes count? It will be 0. Okay. If previously visited nodes count is 0. 4 minus 0 is 4, right? Now, total nodes is equal to, see, I am trying to do this. I have already told you what I will do is total number of nodes into total minus total number of nodes. Okay, this is what I am doing. Total nodes is equal to total nodes minus count of nodes in this component. Total nodes in this case is 7 minus 4, which I am getting from here. 7 minus 4 is 3, right? What is it will contribute to the answer? Answer is equal to, as I have showed in the this example. Okay, what is answer? Number of nodes in that component multiplied by total minus number of nodes in that component. Okay, what I will do is total nodes in that component, which is 4, then 7 minus 4, which is 3, right? And it's contributing 12 to the answer. I will again tell 4 into 7 minus 4, which is 3. 3 is coming here. 7 minus, okay, 4 into 3 is 12. So now my this component previously visited count nodes count will be populated to the latest visited array visited sets length, okay, which is 4 now. Previously it was 0 here. Now it became the latest value. What is the latest value? That is being populated here, right? Now for 0, it will cover all for 0, 2, 4, and 5. All are done in the same BFS traversal, right? Now I will be 1. See, what is I? I is this, right? For I in range, this I'm doing now. This is I. So what I'm doing here is count of nodes in this component. See, there are total four now. I am running the BFS again. So these two will be added on top of that. So 4 plus 2, 6. Okay. 6 is the latest number of nodes in the visited set, right? 6 minus the previous value 4. 6 minus 4, which is 2. Okay. So total nodes is equal to the total nodes minus the count which we are getting here. So it was 7 minus 4, which is 3. 3, and now I am subtracting these two from that. So 3 minus 2, I am getting 1. Okay. Now, like this, I did same thing. I'm doing number of nodes into total minus number of nodes. This I'm going to do now. This step, answer is equal to number of nodes in this component into total nodes. Okay, just 2 into 1 is just 2. So answer will be 12, which is coming from here, plus 2, which is coming from here. 12 plus 2 till now. Okay, and this value, which is 6. Okay, this value 6 will be populated to my previously visited nodes count. Now this second was for 1 comma 6, right? See, for I equal to 0, it covered for 0 to 4 and 5. For I equal to 1, it covered for 1 and 6. Now I am at I equal to 3, right? For I equal to 3, this is a segregated component. It does not have any nodes and anything. So what will happen is, see, previously I had 6 nodes. Now this one node will be added, it becomes 7. 7 minus the previously held value for the set visited set. 7 minus 6 is 1, right? Total nodes is equal to total nodes minus the count, which is, see, it had a count of 1 and last. So 1 minus 1 is 0. So what will happen is, I will be multiplying the counts, which is 1, with 0, which is 0. Okay. So how it is contributing? 12 plus 2 plus 2, see, 12, which is coming from here, plus 2, which is coming from here, and 0, which is coming from here. So 12 plus 2 plus 0. Okay. So now this will be populated to my latest value, which is 7. This is the latest value, which is 7. But does not need, because the loop will end here. So the final answer will be 12 plus 2 12 plus 2 plus 0, which is 14. So this is the thing here, right? Please pause and rewind the video if you have any doubts. Please pause it and see, because I am definitely in first attempt you will not be able to understand it. If you have been following my previous video graph videos, then I hope you will be able to understand this part. See, it's more of maths. This part is fully maths. There's nothing programming here. If you know permutation combination chapters, I think it was in some 8th or 9th class CBSE, then definitely you can do it, right? This is a simple behavior traversal. I've already told how it will work. It will push all its neighbors, then one by one they will be popped out, and their neighbors will be popped in. Okay, and if they're this will happen only if they're not in the visited set. If they're already visited, this won't happen. This I already explained you with examples. If you want, I can paste these calculations also in the comments in the video below, right? That also can be done. And coming to the time and space complexity, see, we are making adjacency lists, so definitely the space complexity will be O of n plus c, because here E and N are not related, right? There is no relation given. In yesterday's question, it was related. That's why it became O of n, right? But in today's question, it's O of n plus c. And time complexity also, whenever we are doing BFS, it will be always O of n plus c, right? So yeah, friends, that's all for today. If you have any doubts, please comment. I will be definitely happier to help you out in discussing. See, the purpose of making videos is to discuss this kind of solutions, right? So yeah, friends, that's all for today. If you really like the video, please like and subscribe. Thanks a lot.